dear students, welcome to my channel Chemistry with ASR. In the previous session, I had discussed about the structural representation of organic compounds. So you learnt about the complete structural formula, condensed structural formula, and bond line structural formula. Along with that, you also learnt about the polygon structural formula, right? So now in today's session, you're going to learn about the 3D representation of organic molecules. What is it? It is 3D representation of organic molecules. This is from the lesson, Some Basic Principles and Techniques of Organic Compounds, Unit A. So this 3D structures of an organic molecule can be represented using certain conventions. What are those conventions? Conventions can be solid wedge, dashed wedge, okay, or normal or ordinary lines to represent the bonds. Okay. Now, let us understand where in this following structure, you have seen carbon, there is hydrogen bonded to a normal lines, right? But you can see that there is dashed line and there is one solid wedge like this, which is shaded. Now what are these? This is a solid wedge which is towards the observer. This is towards observer. This is dashed wedge. This is away from observer. It is away from the observer. Okay. And these two normal lines represents bond lying in the same plane or bond lying in the plane of paper. Alright. So such representations which completely describes the actual position of the various atoms of a molecule in a space is called a spatial formula, or it is also known as 3D structure, or it is also known as three-dimensional structure. Now in this you can see that the wedge bonds are projecting towards you. You are observing the molecule, so it is projecting towards you. The dashed wedge is projecting away from you. Okay, so this is about the three-dimensional representation of the simple molecule called as an methane. What is this molecule? It is methane. It is CH4. Okay. Now let us see, there are some more different ways of representations. There are three ways to visualize the molecular architecture. So what are they? We can use the physical devices for better visualization and preparation of 3D structures of the organic molecules. So these models are made up of either wood, it is made up of wood, or plastic, or it can be made up of some metals. Okay, they are used to visualize the molecular structures. Now these three types includes, one is the framework, next the ball and stick model, and third one is space filling model. This is the space filling model. In case of frameworks, atoms are not shown. Atoms are not shown. Bonds connecting the atoms of the molecules are shown. So you can only see the bonds that are connecting the atoms or the molecules are shown. And it is used only to study the pattern of bonds. Used to study the pattern of bonds in a molecule. So we are going to ignore the size of the atom. Size of atom is ignored. Size of atom is ignored. Okay. Now next type is ball and stick model. Ball and stick model. Here both atoms as well as in ball and stick model, both atoms as well as bonds are shown. And the sticks denotes the bonds. Ball denotes the atom. Okay. Sometimes there will be double and triple bond in the molecule. So in that case, we are going to use springs instead of sticks. Instead of sticks, we are going to use springs. Alright. Next one, space filling models. You can see here, you can see that it is space filling model. This is called as space filling model. And Wedge, what you can observe? Can you tell me? In this you can see that bonds are not shown. In space filling models, bonds are not shown. And it mainly emphasizes on the size of the atom. Size of atom is considered. Okay. And this mainly depends on the van der Waals radius. Van der Waals radius. Therefore, it covers the volume of the atoms that is occupied by the atoms in each molecule. Okay, how much volume of an atom is occupied in the molecule? That is shown by the space filling model. Along with this, we can also use some computer graphics to understand the structure of the molecule, to visualize the three-dimensional representation of the molecule. And you can also see in the screen that I have shown. a three-dimensional view of the methane. You can see when red is in front, it is wedge. When it goes behind, it is dashed wedge. When it is in front, it is solid wedge. When it goes behind, it is dashed wedge. Now observe green ball. When it goes behind, it is dashed wedge. When it comes towards you, it is solid wedge. I hope it is clear, children. If you have any doubts, you can ask me in the comment section. Thank you for watching, children. Meet you in the next train.